Jai Hind everyone. I am Anupam Kumar Saini, Assistant Professor from Akgec Ghaziabad, Department of Information Technology. Today I am going to discuss Pushdown Automata. That is the important topic of automata that is subject of 4th semester. What is Pushdown Automata? Pushdown automata are machines to accept context-free languages. For a context-free grammar, G, there is an equivalent push-down automata machine to recognize the language generated by the grammar. Push-down automata can describe with 5 tuples. Here, basic PDA has the input tape, finite control and stack. This is the input tape where we put the string we have, and this is the stack where push the string as per our requirement. This is the architecture of PDA: input tape, finite control and stack. We can see this is a block diagram of PDA. When we have a string like this 0 0 0 1 0 0 0, this is the input string. We put it in the input tape. First we have to read the input string and push this string in stack and move further left or right. We explain here with example in detail. Basically, there are 2 types of move in non-deterministic PDA according to input symbol, current state and top symbol of the stack. A decision made, then the input had moved ahead 1 symbol. Next move decided by the current state and the top symbol of the stack only. The input symbol is not used. Hence the input head is not moved at all after the decision is made. This type of move is called epsilon move, that allows the PDA to manipulate the stack without reading input symbol. There are 2 ways by which strings are accepted by PDA: with the help of empty stack and with the help of final state. The PDA accepts an input if after reading the input and the machine empty its stack. The set of inputs accepted by the PDA is the language accepted by empty stack, and the second way is the set of input accepted by the PDA is the language accepted by the final state. Means when we design a PDA, we can accept the string with the help of empty stack or with the help of final state. Basically, PDA has 7 tuples: Q, sigma, delta, tau, Q naught, Z naught and F, where Q is a finite set of states, sigma is an alphabet called input alphabet, and tau is an alphabet that is called the stack alphabet. As discussed in architecture of PDA, there is a stack and input tape, then the tau represent the stack symbols. This is input tape, this is stack. When we put any symbol in the stack, then it known as tau, means stack alphabet. For example, if AA, BB is a string, if we put this A in stack, then A become the stack alphabet. Q naught is the initial state, Z naught start symbol of stack, that is Z naught. The symbol of stack symbol are represented by tau, and initial stack symbol is represented by Z naught. So Z naught in subset of Q, that is set of states, and tau is a transition function. Here tau to represent how mapping between states, means how the perform the string. The here the transition is represented by Q into sigma union epsilon into tau, means when the state Q naught, then input symbol, if the input symbol is A and B, this is the input symbol A comma B, and epsilon is used as when there is no any symbol insert, then use epsilon, means if there is no input of A and B, then we can move with the help of epsilon without any change. Tau represent the stack symbol, that is here initial state symbol is stack symbol is Z naught. Then the output is Q into tau star. Tau star is the stack symbol. This is changed with the help of these Q and sigma, and tau symbol is initial state. Now we can elaborate these tuples with the help of example. We take an example how PDA work. We take an example AN, BN, AN, BN is a string where n is greater than or equal to 1, Here we take this example. This is the input tape. This is a stack, and this is finite control. If the question says that a to the power n, b to the power n, means accept the string where a to the power n and b to the power n and n is greater than or equal to 1, then what string will accept here? If we put n equal to 1, then the string ab will accept. If we put 2 in place of n, then a string aa bb will accept. If we take n equal to 3, then here we can see that equal number of a and b will accept. Here is a comparison occur when 1a is there, then string should accept single b and single a. If we take this string a b b, it will not accept here because a number of a and number of b are not equal. So there is a comparison between a and b. So we use for this PDA. Here we use stacks, infinite stack string, number of string in stack can be infinite. So we take this example and how to solve this, how to work PDA. We see here, if we take this string as a b b and b, we take a string w equal to a b b b. This is the string we take to explain the PDA. How it work? If first a we get, then put it in stack. Means if we get first a, then push operation will perform and this a is pushed in stack. First a get we get first a, then we put it in stack. Next we get second a, also put it in stack and push operation will perform here. Until the a occur, it will be stored in stack, means push operation will perform. A, we get a store in stack, means push operation will perform, and now all the a's are pushed in stack. Now here the next step will occur. After completely push a in stack, now we get b. Now perform pop operation with respect of single a, single b will pop. Means at the state of input string is, if we get B, with respect of this B, this A will pop from the stack. In single A and single B will pop off. When we get first B, then pop single A. Now move to the next state. We get B, and when we get B, then go to the stack and see here is also opposite symbol A. Then pop operation will perform, means when get B at this state, A will pop. For this way, all the string will pop and move to the next state and next state. Here we get empty, and initial state of stack is Z0. Then we get that the string is completely executed. For this way, push down automata will perform. How we construct PDA? As we saw in the transition state, Q at transition state, we saw that Q into sigma union epsilon into tau. Then Q and tau star will be the output. Q into tau star will be the output. So we draw a PDA for this. If we take Q naught as the initial state, at the starting state, if there is in this is a state, that is Q naught, this is input symbol. When we get first A, from input string, and Z naught, that is top of the stack, is Z naught. Then output will be A Z naught. How this will occur? At input state, this is a string A, B, B, and B. This is an input string. This is stack. Initial state is Z naught. when we get first A, this one initial state of stack is Z naught, then what will be the output? A Z naught. Now we put Z naught A and remove this one A from here and push it in stack. This is written as A Z naught. For this way, first step will perform when we get A Z naught in stack. Means push operation perform and first A push in stack. Now if we get next A, this one, this A, and top of the stack at this time is A, this is top of the stack, and input symbol at this time is pointer of the input tape is here at A, and top of the stack symbol is A. We write A. Then what will be the output? Output will be AA. Means we push this A in stack. Now AA will be the in push in a stack. For this way, there is a loop represent that multiple A's can be pushed in stack. This A also push in stack with this A and output is A comma A means input tape symbol A, top of the stack symbol A, output AA, and next this is the transition represent that input symbol A means initial state. At this state Q is Q naught, sigma is A, tau is also A. Next state here, next state is also Q naught and tau symbol is AA, tau star is AA. For this way, push all the A's in stack symbol, in stack, all the A pushed in stack. Now we get first B, then we perform pop operation here with respect to single A and single B, then pop operation will perform. When input symbol is B, top of the stack is A, then pop operation will perform and represented by epsilon. Now go to the next state Q1. With respect to this B, this A will this B will pop with this A, B, A, and output is epsilon represent there is a pop operation performed. For this way, next B, now pointer move to the this B after that, and here the pointer is here at A. Then with the help of this B in this and this A, we perform pop operation B and A. Epsilon means the pop operation perform, and here this A will pop with this B. For this B, all the B's will pop with the help of stack symbol A. Now this we already popped. Now pointer move to this B, and here at this place. Now with the help of BA, we pop B and A, means pop the A from stack and pointer move to the next, means now the pointer move Z0 and here we put epsilon. Now the pointer is moved to here. Next step we get epsilon, means all the string get executed. No input symbol is here, and at this point Z0 is here. Then we can say that the string is except here. We can write it as a input symbol is epsilon, top of the stack at this point is Z0, and output will be epsilon, means there is no any input symbol in input tape and no any stack symbol is stored in stack. Then we get this PDA where the string is except when AN B N. This is a PDA for this. We can accept this with the help of final state also. With the here without final state means except with the help of empty stack. Except with the help of empty stack. If we put it at, we can use final state QF in place of this. Input tape symbol is epsilon, stack symbol is Z0. Next output will be Z0, means there is no stack symbol occur. Then we get the we reach at the final state. So these are the first way with the help of empty stack, with the help of empty stack we get output, means we reach at the final state. And the second way with the help of final state with the help of final state. These are the two ways where PDA get the output. Means first accept with the final state, string accept with the help of final state, and string accept with empty stack. These two ways where we get the string in PDA. A to the power n, b to the power 2n, where n is greater than or equal to 1. So this question is for practice and we will discuss in next class. Okay.